Hey, welcome to For Education. I'm your host Phil Kuhnke, and today in our series in linguistics, we will talk about the science of speech, the sounds of human language. So let's get started. Human speech sounds are studied in two fields, phonetics and phonology. So phonetics studies the properties of speech sounds in general. So phonetics is independent of any particular language. Phonetics studies all of the sounds that you know as an English speaker, for example, k, r, o, u, I, a. But it also studies sounds from other languages, things like that may occur in African languages or something like that, but for example, not in English or German, French. Phonology, in contrast, investigates the role of speech sounds in different languages. So it is obviously built upon phonetics and is dependent on some particular language. So let's get started with phonetics first. In phonetics, we try to describe sounds by their articulatory features. And this is done in consonants using manner of articulation, place of articulation, and voicing. And here we have a typical table of the International Phonetic Alphabet that is typically used to do phonetics. It is also called the IPA. And in the columns here we have the place of articulation, and in the rows we have manner. So manner includes things like plosives, nasals that involve the nose somehow. Then we have fricatives, and so on. In place, we literally have the place in your mouth where the sound is produced. For example, dentals involve the teeth somehow. You can see that there are sometimes two sounds in one cell, and then these differ by voicing. So, for example, p is unvoiced and the b is the voiced bilabial plosive. For vowels, the articulatory features that are used are so-called height and backness. Height, we have high, mid, low. High is also sometimes called close, and low is also sometimes called open. And in backness, we have front, central, back. And this kind of tries to model where the sound is produced in your mouth. So front high sound would be I as in pit. A mid kind of front sound would be as in pet. And then we have a low, almost central sound, the as in pet. And the central mid sound would, for example, be the as in pittance. This sound is called the schwa. And then we have back sounds, the o as in put, the a as in pat, and the o as in pot. So here's the entire IPA table for vowels, and you can see that there are sometimes, again, two sounds at one place. And then always the right sound is the rounded version. So for example, this is the round front close vowel, and the left version is always the unrounded counterpart. So for example, this would be the unrounded front close vowel. And finally, we have this sign for vowels that kind of looks like a colon. This is the sign for lengthening of a vowel. So this can be very important to even distinguish two words. As in English, we have the two different words fit and feed that only differ in that the E sound is lengthened. Okay, so let's move on to phonology. Phonology now categorizes sounds that actually make a distinctive difference in one particular language. And for that, we need to know, first of all, the notion of a phone. A phone is any sound in human language. And now phonology groups these phones in so-called phonemes. Phonemes are abstract categories of sounds where sounds of different categories make a distinctive difference. They have to be differentiated in the particular language. And then we call allophones different realizations of one and the same phoneme. So different phones that are in one phoneme. And I always like to visualize phonemes as these bubbles or sets if you're into mathematics, where, for example, here p is one phone in a particular phoneme, and there will be different allophones in this phoneme as well. And now, how do we decide whether two phones have to belong to different phonemes? We typically do this by using a minimal pair. A minimal pair is a pair of two words that share all but one sound. And then we can say that the sounds that differ have to belong to different phonemes. So, for example, pet and bat are two different words in English. They mean different things. They're not the same word. So p and b, the sounds that differ, have to belong to different phonemes. So we need another one of these bubbles where we put the b sound. And when we find such a minimal pair, we can say that they are in overlapping distribution. This fancy linguistic term means that we find phonetic environments where both phones occur. And phonetic environments just means the sounds before and after. And complementary distribution is the term for saying that they are not in overlapping distribution. So we do not find such a case where the phonetic environments overlap. And then they are typically allophones of the same phoneme. So, for example, in English, this is the case for the normal p and the aspirated p. So, for example, the aspirated p occurs always if the sound occurs at syllable onset and is followed by a stressed vowel. So, for example, in pin, and in any other case, the non-aspirated p is used. So, for example, in spin. The aspirated p and the normal p are indeed in complementary distribution, and that is why we can put it into the same bubble. The same holds for the aspirated b. Here's some further examples of minimal pairs. For example, we have will and bill, which only differ in their first sound, w and b. So w and b belong to different phonemes in English. Then we have bill and bit. So and t belong to different phonemes. Then we have will and wall. So I and o are phones of different phonemes. And finally we have word and weird. And here you can see quite nicely that it's not about the spelling at all. It's just about the sounds. These two words, of course, differ in more than one letter, but they only differ in one phone. And similarly, thrill and bill is not a minimal pair because these two words differ in more than one phone. Let's have a final example of phonetic environments so you really get the idea. Here are a few examples from German, and the two sounds we want to look at are the ch and the ch. For ch, we have the examples acht, which means 8, Buch, Loch, Hoch, Flucht, and Lachen. And for ch, we have the examples ich, which means I, echt, sprechen, lächeln, riechen, and fechten. So now we can ask ourselves, what are the phonetic environments in which ch and ch appear? So we find ch always occurs after a, u, o, or u, and before e, t, or its word final. And the ch always occurs after I, or e, and before e, t, or its word final again. And so, are ch and ch in complementary distribution? Yes, indeed they are, because there's no example where ch and ch appear in the same phonetic environment. Ch always appears after I, or e, as we saw, and ch after any other vowel. So there's no case where the distribution overlaps. So do they belong to different phonemes? No, they don't. They are allophones of the same phoneme because they are in complementary distribution. So now we can put ch and ch into the same bubble. They are allophones of the same phoneme. So that's it for today. If you'd like to see more educational videos from us, please subscribe. I'm Phil from For Education, and I will see you next time.